My name is Christopher Micklejohn, and I'm going to walk through the design of an eventually consistent advertisement counter with Lasp. We're going to start our simulation now because it takes a moment to run while I explain how the simulation will be executed. For our eventually consistent advertisement counter, we assume that we maintain a bunch of counters for different providers. We group these into sets, and we union these sets together. We compute a equivalent to a SQL join using a product and filter combination with contracts, which are the ability for ads to be displayed. So we look for the ads that have contracts that are valid. Once we combine them, we end up with a set of advertisements and their counters that are valid to be displayed, and we send these to the clients. We model each client as an Erlang process in our simulator, and we use message passing driven by the simulator to share state with that client, and then that client will periodically synchronize that state back with some centralized server or whoever the canonical source is for that piece of data. Clients will modify their local copy of the ad counter and periodically synchronize back. And when that ad counter reaches 50,000 impressions, we'll disable this ad in a monotonic fashion. And this is what the dotted red arrow in this graph, this data flow graph, represents. It's important to realize here that counters, if we had a third-party observer who could see the value of all counters, that the count recognized by a single node in the system will always be delayed versus as compared to the global count. So there'll be some notion of divergence, and that will be a factor of how often clients synchronize with the centralized server. Now we see that our simulation has completed, and in our simulation we've hard-coded a synchronization interval of 10 milliseconds. And this is configurable in our simulator to have it run in arbitrary intervals. And the number of clients and events are configured. And I've kept them low for this demonstration so the test would execute quickly. We see that at the end of the run, for each client, it's overcounted by approximately 5.2 advertisement impressions. We have 10 clients, so this results in a total overcount of 52 advertisement impressions. And if we were to tweak this interval here and have clients synchronize, reduce this so clients synchronize on every single write, then that would lower that divergence gap. So that is the design of an eventually consistent advertisement counter using Lasp.